All right, class, here we go. Today we're going to learn about exponents and scientific notation. I'm going to teach 5.1 and 5.2 together because they're like a mix of all of these exponent rules and things. And so it's kind of a weird combination. I don't see any point in teaching them as separate sections, so I'm going to teach them together. So real quick review of exponents. This is the base here. And this is my exponent. My base tells me what is being multiplied, and my exponent tells me how many times. So again, exponents are abbreviations for multiplication. So if I have 2 to the 4th, then that literally means 2 times 2 times 2 times 2, which is 16. So when we are talking about all of these exponent rules, okay, that I have written over here, all of these rules only apply to exponents. You can't apply them in any other way. All right, so let's see if we can discover a few of these exponent rules. Okay, so if I had y squared and I wanted to times this by y cubed, by simply expanding it like we did here, we could say, well, this one means y times y, and this one here means y times y times y. And the parentheses means that it's all being multiplied together. So if I were to take it from this expanded form here, which is what this is, this expanded form, then I could take it from expanded form to exponent form, and you can see that the simplest way to say this would be y to the 5th. Okay, so what that means is that when you multiply exponents, when the bases are the same, this only works if the bases were the same. So if I had like y squared and I wanted to times this by x cubed, I can't combine their exponents because they have a different base. That would be bad. Okay, so this only works if you have the same base. So when the bases are the same, here's the rule. Mathematicians not super creative, so they're literally like, I know, let's call this the product rule. Well, remember that product means multiply. So basically they're saying, this is the rule for multiplying exponents. Okay, if you have the same base, then the relationship of the exponents is addition. You can see here that y 2 plus 3 is equal to y to the 5th. You can visually see what happened here. So when you're multiplying bases, then you add the exponent. Okay, well, how is that different than, say, this? X squared, but raising that to the 3rd power. Well, remember that expanded, this literally means x squared times x squared times x squared. Because this exponent says I have everything inside of here 3 times. 1, 2, 3 times. Well, what does x squared mean? X squared means x times x. So I've got that 3 times. And they're all being multiplied together. We can see that I literally have 1, 2, 3, 4, 5, 6 x's being multiplied together. So then what is the relationship of these exponents? Well, x, 2, and 3, their relationship in this case is multiplication. Okay, it's 2 times 3. So again, over here, this is a power or an exponent being raised to a power, so it's called the power rule. And when that's the case, I'm going to multiply their exponents. So this is the reasoning behind the rule. This is the why, and here's the rule. I highly recommend memorizing every single one of these rules and knowing how to use them in any situation. So again, by expanding each of these, I can prove that this is the rule. There's literally 2 y's here and 3 y's here, so there's a total of 5. But here there's a total of 2 x's, 2 x's, 2 x's, so there's a total of 6 x's. So you can see the difference in the relationship. The difference is that this one is multiplying bases, and this one is a power being raised to a power. Okay, well, what does that power to a product mean? Whoops, I just deleted that. A power to a product means that I just have more than one thing inside. Well, you guys already know how to do this. We've done this a lot. So if I had negative 2x and I wanted to cube this, this literally says that I have negative 2x 3 times. So I have everything inside of there 3 times. And if I have everything inside of here 3 times, then negative 2 times negative 2 times negative 2 is a negative 8, and I have x cubed. So again, it's not just the x that's going to be cubed. All this product to a power rule says is if you have something inside a parenthesis that's being multiplied, which this is, -2 times x, and I'm raising all of that to the power belongs to every different base. Okay, so it belongs to the A, and it belongs to the B, and it belongs to C and D, and whatever else might be in there. Because it's literally saying take everything inside of here and do it 3 times. Okay, so really, I could think of this as -2 cubed x cubed. And this would give me, again, that -8x cubed. So you can see it expanded here, and you can see the exponent rule here. Okay, let's do another one of these with this product to a power rule. Let's say that we have 3a cubed b squared, and I want to raise this to the second power. Well, then what this is saying is 3 is a different base, a is a different base, and b is a different base. So a, or 3 squared, is 9. A to the 3 times 2 is a to the 6th, because I have 3 of them, and then I have another 3 of them. That's what this says. And b is 2 times 2, which is b to the 4th. Okay, so this is considered simplified. So that's, again, the product to a power example. For the quotient rule, we are going to have, let's look at, if we had, say, let's do, say we have p to the 5th, and that's going to be over p cubed. Well, what does p to the 5th mean if I were to expand it? Just like I expanded this 2 here, it literally means 1, 2, 3, 4, 5 p's related through multiplication. And that's all going to be divided by 1, 2, 3 p's related through multiplication. So remember that anything divided by itself is 1. So I can cancel from top to bottom this p, and this p. You can see here that all I have left is p squared. Okay, if that's the case, then what is the relationship here? These exponents. 5 times 3, 5 divided by 3, 5 minus 3, 5 plus 3. So what is the operation that's happening here? And you can see that it's subtraction, 5 minus 3. So again, that when you're using the quotient rule, the relationship of the exponents is subtraction, and again, you always put the top one first, because remember that in division order matters, and so we need to always have the top number first. So what would happen if this was flipped around? So we said this is p squared, which you can see it's p squared over 1, which is just p squared. Okay, but what if I had q squared over q to the 6th? Well, q squared just means q times q, but q to the 6th means I have 1, 2, 3, 4, 5, 6 of those puppies, right? Well, if I were to go cancel, then top to bottom, anything divided by itself is 1. Remember, I leave behind a 1. Then what do I have here? Well, I have 1 over 1, 2, 3, 4, q to the 4th. Okay, well, what is the relationship of these exponents? Again, the order that you put these in matters. But what's really weird here is I go to use this exponent, it says like 2 minus 6, and what I really get is q to the -4. How does q to the -4 get to be this? Well, if this rule is true, but this is what we got, these two things must equal each other. And that is indeed the case. Okay, so what am I talking about? Well, if you have a negative exponent, you can see here, if anything that you have is raised to the negative exponent. So if I have b to the -5th, this rule right here says that's the same thing as 1 over b to the 5th. I like to think of exponents as like upstairs and downstairs, or like kids. Okay, if a kid's being naughty, then you send them downstairs to the dungeon. No, I'm just kidding. Okay, so I'm still kind of trying to grasp this whole negative exponent thing. So let's see if we can discover this in another way. So let's keep going with this pattern here. If I had 2 cubed, that would be 1, 2, 3 of these 2's. Oops, I was saying 3, so 2 times 2 times 2 is 8. If I had 2 squared, this would be 2 times 2, and that is 4. And if I have 2 to the first power, that would just be a single 2, and that would be 2. And if I have 2 to the 0, okay, now let's see if we can figure this out or prove that negative exponents really do turn out like this. We're also going to discover this rule right here. So notice that when you go up in exponents, you, like for every exponent that I go up, so when I go from 1 to 2, I have 2 of the base, 3 of the base, 4 of the base, etc. I multiply by the base as I go up. That means when I'm coming down, I'm dividing by the base. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So as I go up in exponent, I'm increasing by the base. And as I go down, I'm decreasing by the base. So that means then that 2 divided by 2, remember that anything divided by itself is 1. Okay, anything to the 0 power is 1. We're going to come back to this in just a minute because we're still working on discovering this negative exponent stuff. Okay, so if the pattern continues and I say I'm going to divide this by 2, this literally means I'm going to have 1 and divide it by 2. Well, you can see here that that's the same thing as 1 over 2 to the first power. Okay, so 2 to the negative 1 is the same thing as 1/2. That's what this rule says, and we just show the pattern and the reasoning behind the why. Let's keep going here. If I divided this by 2, oof, what does that say? Okay, well that says 1/2 divided by 2. Remember when you're working with fractions, you copy, okay, 1/2, dot, and flip. So this would be equal to 1/4. Okay, so the value here is 1/4. Half, or dividing 1/2 in 2, if you had a half of something and you shared it with 2 people, you would now have a 1/4. Well, a 1/4 is the same thing as 1 over 2 squared. And then you can see here that this negative exponent, if it goes to the basement, then becomes positive. Okay, so that's our negative exponent rules. For this 0 exponent rule, let's talk about this for just a minute. If anything to the 0 power is 1, then let's do a few problems. Let's say that we have x, y, z to the 0 power. We have a negative 2 to the 0 power. We have I don't know, let's say that we have a negative 9 over x to the 0 power. How does this 0 power thing work? Well, remember that exponents only belong to whatever they're closest to. So in this case, it only belongs to the z. So z to the 0 power is 1, which just means that the x times y times 1, because that's what z to the power is equal to. Z to the 0 power is equal to. So we get x, y here. Well, what about this one? Well, again, that 0 power only belongs to the 2. So 2 to the 0 power is 1, but I still have this negative. So this is negative 1. Well, what about x to the 0 power? Well, this 9 doesn't belong to that 0 power, just the x does. So this literally says negative 9 times 1. Well, negative 9 times 1 is just negative 9. Now, how would this be different if we had parentheses here? So say like we have in here 5x squared, and this is to the 0 power. Well, if this whole thing is to the 0 power, this is just going to be 1. And if I had negative 3 y cubed, and this was to the 0 power, this is also going to be just 1, because everything inside that parenthesis belongs to it, and anything to the 0 power is 1. But remember that the exponent only belongs to whatever it's closest to. So you can guarantee that you'll see this concept on the exam and have to apply it in the future. Okay, so we've gone through the product rule. We talked about if you're multiplying bases, how you add their exponents. We've gone through the power rule. So if you have a power being raised to a power, then you times the exponents. We talked about the product rule. If there's more than one thing inside, then everything inside belongs to that exponent. Okay, we talked about if you have the quotient rule, how you subtract the exponents. And we haven't talked about a quotient to a power, but we did talk about the 0 exponent rule and negative exponents. I want to give you a couple more negative exponent examples and then go to a power of a quotient. So what happens though if I had 1 over 2 to the negative 3? Well, remember, if your bad boy is being downstairs, then you're going to send him upstairs, and this is just going to be 2 cubed. 2 cubed does equal 8, so the answer here would be 8. So what if though I had, let's say I have 3 over negative x to the negative 7. How would I simplify this? Well, remember that these exponent rules are only exponent rules, so my goal here is to get this exponent to be positive. This is a constant, the constant of negative 1. I can't just put it upstairs and make it positive. Okay, so it does not apply to this constant, so don't try to apply this negative exponent rule to constant. Well, if I want this to be positive, then I'm going to take its base and the exponent and put it upstairs. So there's already a 3 up there. Now there's going to be x to the 7th up there. But that's all being divided by negative 1, because this negative 1 is still here. By putting the x to the 7th upstairs, we did not make that positive. We made only the exponent positive. So what this really is negative 3x to the 7th. Okay, so that's kind of a more examples of negative exponents and how they work. Let's do maybe another couple here for just simplifying a negative exponent. Let's say that I have 5a to the negative 5b squared all over 15a squared b to the negative 3. And I would like to simplify this. Well, we never really defined what simplify means. Well, simplify, when you're simplifying exponents, remember all these rules only apply to exponents. When you're simplifying exponents, that means that you can't have any negative exponents. So right here, I've got to figure out what to do with these 2 negative exponents. I can't have any powers to powers. Well, there's no powers to powers here, so we're good. But then I can also have each base occurring only once. So when I'm done, I should literally only see A 1 time, and I should see B 1 time. And then, of course, it goes without saying that any constants should always be simplified. So you should put them in lowest form. Okay, so let's start by doing that. So 5 and 15 both have 5 in common. So if I divide a 5 out of both of them, then I'm going to get 1 over 3. Right now, this a to the negative 5 is being bad. So to make it positive, I'm going to have to put it downstairs. But this a squared is already down there. It's going to stay down there. What about the b squared? B squared's being just fine. He's like your kid that's like quiet and easygoing, you know. But what about this b to the negative 3? Well, it's being bad, so it's going to have to go upstairs. And when it goes upstairs, it becomes positive. Okay, so this is what this problem looks like. So I've now cleared out my negative exponents. There are no negative exponents here. But even though I don't have any powers to powers, I still see b twice and a twice. So I need to fix that. So, and 1 times anything is going to be itself. So I just need to write this in the most simplified form. Well, remember that I have 1, 2 b's here, 1, 2, 3 here. So for a total of 5 b's. The relationship of these b's are addition because they are being multiplied and product means multiply, so I'm going to add them. Same thing here. So I'm going to have b to the 5th over 3a to the 7th. This is all the way simplified because there are no negative exponents. The constants are simplified. I see each base only once, and there's no more powers to powers. Okay, so that is kind of what you would do with negative exponents. But what if these puppies are inside, and I have several things inside of an exponent? So I've got multiple bases that I need to raise to some powers. So say we have 3m to the 5th over, I don't know, 2n to the negative 4. But I want to raise all of this to the second power. Remember that this literally means that we have everything inside of here twice. So it would be as if you're seeing this twice. So if that was the case, again, I would never do this normally, but just to show you. If that was the case, then I would have 3 times 3, which is 9. I would have 2 times 2, which is 4. I would have m to the 5th times n to the 5th, which is m to the 10th. And then I would have n to the negative 4th times n to the negative 4th. Well, again, when you multiply exponents, you add them. So this would be n to the negative 8th. This is one way to think of this, but it's better to just think, hey, this exponent belongs to this and every different base, right? It belongs to all of them. That's what this rule says. If I'm raising a power to something that's already being divided, so that's a quotient, right? So inside of here, 3m to the 5th divided by 2n to the negative 4 is a quotient, but now I'm raising it to a power. Well, all this says is that the power belongs to everything, which we already knew, because when we expand it, it belongs to everything inside. Okay, so I would get the same thing here if I say, oh, 3 squared is 9. M to the 5th times 2, 5 times 2 is 10. 2 squared is 4. Negative 4 times 2 is negative 8. But if I couldn't stop here, and a lot of people are like, I never know when I'm done. How do I know when I'm done? Well, I can't simplify 9 and 4. I see m and I see n only once, but here I still have this negative exponent that I need to take care of. Well, how do I take care of this negative exponent? Notice that I circled its base. It does not belong to this 4. It only belongs to the n. That means it's going to have to go upstairs to be positive. So I'm going to have 9m to the 10th, n to the 8th, all over 4. And this would be all the way simplified. Okay, so we can get a little more complex here. What if I had negative exponents that I wanted to multiply? So I'm just going to go through several different scenarios and examples here. Probably, I don't know, 5 to 10 of them real quick, and show you kind of how I would approach these problems. But once you know all of these rules, you should be able to work out any problem. Something from as easy as this to or this to something like, I don't know, let's say 4 something like this. Goodness. To the big kahuna. Let's call this one the big kahuna because it's going to be crazy. Well, actually, I don't want to write too many things on here. Okay, so looking at this first problem, 3 is grand. It can stay right where it's at. I don't care. And in fact, let's make this 3 negative just so that we can drive home this point here. I cannot make this negative 3 positive by putting it downstairs because it's a constant. This constant says it has a value of negative 3. If I put it downstairs, I'm changing the value to a negative 1/3. 1/3 of a dollar is definitely not the same thing as $3, so I don't want to change the value. So I cannot apply the rules of exponents to this -3, but I can apply them here. And remember, to simplify means to get rid of any negative exponents. So the simplified version then of this one would be -3 over p cubed z squared. I'm just going to put those into the basement, and what do you know? They're golden. Okay, same thing here. I can't combine any of these bases because they're different variables, just like these were different variables, but I want this x to be positive, so I'm going to say, nope, dude, go downstairs. And I want y to be positive, so I'm going to tell him to go upstairs. So I will get y to the 5th over x cubed. Okay, so that is simplified. All right, well, what about this one? Well, this is a a big product rule, but it's fine. We know how to do all this. This literally says that I have 4 times x cubed times y squared times -8 times x to the 5th times y to the 7th. So it's all related to multiplication. No sweat. I can do 4 times -8. That's 32. Okay, x cubed times x to the 5th is going to give me x to either the 8th or the 15th. Which one is it and why? Well, it's going to give me to the 8th because I'm going to add these exponents because it's all related to multiplication. It's a product. So 3 plus 5, I have 3 here and 5 here for a total of 8. They expand to the same thing. Here I have 2 y's and 7 y's, which is going to give me a total of 9 y's. So that is simplified there. Okay, well, what about this one? X to the 8th raised to the -4. Well, this is a power raised to a power, so I've got a power raised to a power, so I'm going to multiply these. 8 times -4. Oh, hey, I wrote that here. Let's do -3 just so it's not the same. 8 times -3 is x to the -24. Now, although I've gotten rid of my power to power here, I still have a negative exponent, so to make it positive, I need to put it downstairs. This is simplified because there's no power to power, there's no negative exponent, and I see the base only one time. Okay, now I want to do 2 kind of larger problems, and then we'll pause this video or stop this video, and this will be all of the exponent information that you're going to need to deal with. So let's do let's do this. Again, mixed with all these negative exponents here. This exponent belongs to every different base. Remember that if I have a product, which this is a product, all these are related to multiplication, then the exponent belongs to all of it. So 5 to the -3, so I have 5 to the -3, a to the 3 times -3, which is -9, b to the -2 times -3, which is a +6, and c to the -4 times -3, which is a +12. Okay, so I've got rid of my powers to powers. I no longer have anything being raised to the power. I should see each base only once, which I do. Only problem here is that I see negative exponents. So to make this positive, I'm going to have to put him downstairs. That's 1 over 5 cubed. This a is being naughty as well, so I'm going to have to put it downstairs. That's going to be a to the 9th. This b is going to stay upstairs. We're going to have b to the 6th and c to the 12th. There's nothing more to do with that. Again, this 1 here was just so that I could put this 5 downstairs, but 1 times anything is itself, so I'm just going to erase that. This is not considered all the way simplified though, because I actually know the value of 5 cubed. So I will have b to the 6th, c to the 12th, over 5 times 5 times 5, which is 25, which is 125. So over 125, a to the 9th. Now I have simplified this all the way. Okay, so that is kind of a bigger problem. Let's do 2 more here. Let's do All right, so this is a crazy problem. So where you start or how you choose, the order in which you choose to apply these exponent rules doesn't matter, but your life will be easier if you use strategy. So for me, I'm going to say I'd rather not multiply all these exponents. I'd rather simplify inside first. So let's look at the inside and simplify everything that we can before we deal with this. All right, so 4 and 12 we'll reduce to 1/3. A to the 6th and a cubed. Well, there are 3 more of these puppies upstairs. So think, there's like 6 kids upstairs and 3 kids downstairs. Basically, this problem's like, how many more are upstairs? You're gonna be like, oh, that's 3, right? Okay, and really doing a to the 6 minus 3, which is a cubed. And of course, it's gonna go up top because if it was 1 over a cubed, that's different. These are not the same. Okay, so this b to the 7th, it's gonna stay upstairs. And the c is going to stay upstairs, but this b right here, he's being naughty and he needs to go upstairs. So his exponent is going to become positive, and same with this c. He's being naughty, so he's going to go upstairs as well. So this is kind of crazy. So what do we have? Well, we have a cubed upstairs, b to the 7th times b to the 2nd is b to the 9th. Remember, we're adding these exponents, and we have c to the 4th. We have 4 of them. C times c times c times c, all over 3. 1 times anything is itself, so I don't need to worry about that. We're going to raise this to the -2, and we will get then a to the -6, because 3 times -2. B, 9 times -2 is the -18. C to the -8, and 3 to the -2. Now notice that this is really ugly. Another thing that you could do here is that you could just say, hey, if I have a quotient, and the exponent is negative, what's going to happen is that it's going to be negative. Everything inside will be negative. So really these will end up opposites. Okay, well then we could just flip this to begin with and make this exponent positive. You can see that they equal the same thing. So instead of doing this, I would recommend just flipping the whole dang thing, writing it like this, and then saying, let's raise that to the it'll be positive now, because since I flipped this whole thing, this exponent became positive. You can see that that's what happens if you flip, that this negative expression right here with the negative exponent becomes this, which is what we just did. Okay, so from here or here, doesn't matter. You can see that in the end, we would have 3 squared on top, which is going to be 9. Okay, this is 3 to the -2. I'm going to have to flip it upstairs to make it positive. I would have a to the 3 times 2, which is a to the 6th on the bottom, or I would have to put this one downstairs to make it positive. So again, lots of different ways to do this, but it's up to you. 9 times 2 is going to give me b to the 18th, and 4 times 2 is going to give me c to the 8th. So whether you multiply them as negatives and flip them, or you flip the entire thing, you will end up here after you have gotten rid of all of the negative exponents. All right, so that's the end of this video. I'm going to do a part 2 of this, and we are going to discuss scientific notation. So hold on to your hats.